Good morning to everyone, and welcome to day 2 of the Northeastern University Energy Systems Society 6th Annual Energy Conference. We're really excited to have everyone back who attended yesterday, and welcome to all our panelists who are joining us today. So today's first panel is titled The Future of Energy Storage, and this panel focuses on both the industry and research aspects of batteries and other forms of energy storage, while also addressing sustainability in the field. And if time permits, we'll briefly discuss green hydrogen at the end of it. So this morning for our moderator, we have Professor Hongli Julie Zhu. She's currently an assistant professor at Northeastern University. Her group focuses on the research of electrochemical energy storage, biomass-derived multifunctional materials, and emerging advanced manufacturing technologies. From 2012 to 2015, she worked at the University of Maryland as a postdoc, focusing on the research of flexible electronics and energy storage. From 2009 to 2011, she conducted research on material science and processing of biodegradable and renewable biomaterials from natural wood in the KTH Royal Institute of Technology in Sweden. Her expertise is on the research of environmentally friendly natural materials, energy storage, design and application of bioresource materials in the advanced materials and advanced manufacturing. In energy storage, her group at Northeastern works intensely on solid-state batteries, flow batteries, and alkali metal ion batteries such as sodium, lithium, potassium, etc. Welcome, Professor Zhu.
Hello.
Our next panelist is Ms. Judith Judson. She joined Ameresco in January 2020 as the VP of Distributed Energy Systems after holding top positions for the Commonwealth of Massachusetts, most recently serving as Commissioner of the Department of Energy Resources and previous Chairman of the Public Utilities Commission. In her role, Ms. Judson utilizes her breadth of experience to help clients navigate the dynamic and volatile energy markets and is responsible for recognizing opportunities to leverage renewable and advanced energy technologies for clients to reduce cost, lower emissions, and increase the resilience of their operation. Welcome, Ms. Judson.
Hello, good morning.
I'll hand it off to you, Professor Zhu.
Thank you, Jonathan. Thanks for the introduction. And welcome everyone to participate in this panel. The first question is, what is the current status of the energy storage industry? And what will energy storage look like in the future? So what is the status of the energy storage industry? And what will the energy storage look like in the near future?
Yeah, I can dive in.
Jump in. So, and Judith Judson with Ameresco. So I started in the energy storage space in 2007 and completely agree with Brett. At the time, we were really excited at the company I was with then to do 200 kilowatt projects, one in New York and one in California, to really prove out the technology. And at the time, I would say, the largest projects we were doing were 20 megawatts. Now you're seeing much, much larger scale projects integrating to very large renewable systems. But that said, we're also seeing in my role at Ameresco, a lot of storage behind the meter, a lot of storage at customer sites. And the reason for that is a few things. One, it's an opportunity to add to a customer's energy portfolio. So at Ameresco, we do energy efficiency, we do distributed energy resources, solar, CHP, and now we're adding battery storage to a lot of our projects because the customers want resilience. They want the ability to manage and better align, basically when they're generating energy, if they have solar, with when they're using energy, and therefore that enables them to reduce their energy bills and reduce their demand charges. And that ability that in a power outage, being able to microgrid an island is also, particularly in some parts of the country, becoming more and more of an interest. So I think there's two big trends happening. One is that you're seeing, as Brett said, these very large scale deployments on the wholesale transmission level. And then you're also seeing a market for storage located at customer facilities so they can better manage their energy costs, reduce their energy costs, integrate renewables to reduce emissions and have that resilience. So I think there's a tremendous amount of growth happening, and I think it's happening along those two sectors.
Thank you. Thank you. Yeah.
May I add? Yes, thank you. I wasn't.
I'll just add that, I think there's been a lot of work done to reduce the cost of storage, and it's come down quite rapidly. I would say right now, lithium ion tends to be the technology that is utilized, and it's utilized for a couple reasons, particularly in our projects. One is because it right now has a lower cost relative to other technologies. But it's also proven out. So there's a level of comfort. There's a level of comfort from both the end use customer with that technology. Of course, they also have it in their cell phones and in their computers and laptops, in their electric vehicles if they have that. And then investors are comfortable with it as well. But that said, I think to continue to really grow the industry, this continuing, wanting to see continual declining costs are going to be very important. And and from my work when I was at the state, we were seeing some really interesting new technologies, particularly here in Massachusetts. There's some startups that are working on some long duration technologies that will hopefully be at a significantly lower cost. And I think if you unlock that potential, you'll continue to see a real growth of storage, both standalone and paired with renewables. So, and the last thing I'll say, and I know it might be for a later time, but hydrogen storage, in Amoresco, we're working on renewable natural gas, which can be used to then produce hydrogen. I think there's some interesting activity in that space to provide long duration storage. Again, there's work to be done on cost, but I think there are trends coming down, and I think if other technologies can reach certain cost points, you'll see them grow.
Yeah, I agree. Thank you. I think that different applications require different technology. Like the large scale grid storage, maybe we care more with the cost, with the abundance of the materials. For the portable electronics, people care more with.
Okay, thank you.
Yeah, and we're seeing similar. We're seeing that with our project. So where there's interest in pairing storage with solar, so that a customer can do demand charge management as well as having that resilience and possibly do other services as well with the battery. It does need to have that cycle life, and you don't see that with just a lead acid. So if you just want something for backup, you still see lead acid being utilized, or just for that UPS application. But if you're planning to cycle and utilize the resource, then you really look for cycle life, and you start to, I think, in the industry, oftentimes you think about costs not just on $1 per kilowatt or $1 per kilowatt hour, but also on $1 per cycle, because you're trying to get the best cost for the performance you're looking for.
Thank you. It seems lithium works well, but we need to further reduce the cost of lithium, lithium storage. Let's go to the next question. So we discussed a lot for the large scale grid storage. The next question related to the electric vehicle. Can you speak about the energy storage for electric vehicle charging stations? The charging stations, because it's the fastest growing trend in the industry. What are some of the other current market driver or trends you are seeing around the energy storage?
I can speak to that. Schneider.
Yeah, I think there's some interesting opportunities with pairing stationary storage with electric vehicle charging, particularly with fast charging. So what you see with customers that install fast charging on their systems, they get these spikes in demand charges on their utility bills, which they're not expecting. So they're expecting, clearly an increase from increased electric usage, but not an increase in demand charges. And that has become a barrier to the installation of EV charging technology. So much so that there's been utility rate cases to look at ways to mitigate some of those charges. And then I think a response from the industry is to have that stationary storage paired with the fast charging in order to levelize the draw from the grid while being able to let someone plug in when they want to. Now, if you have storage or you have charging at home, you can just schedule your charging. You can have, but if you have, for example, charging along the highway at a rest stop, you're not going to be able to tell someone they have to wait in 2 hours till the rates are down or something. So
unless they serve good hamburgers there.
Oh yeah, yeah. There's somebody with a business model to make it really great to stick around while they're charging their car. I think there's some interesting things there. But I think if you can add stationary storage, again, I think it's going to look at how much is the cost of that stationary storage. You can enable fast charging stations to be really responsive to when drivers want to charge and yet not have major peak spikes on the grid. So I think you're going to see that trend grow. I think it's still early, but we're seeing interest from our customers, and I think it's exciting that those opportunities are starting to happen.
Thank you. The Department of Energy, they also put an effort to increase the charge speed for the fast charge. Now we work on the technical issue because when we do fast charge, the lithium will have dendrite issue. So the lithium will deposit on the graphite and have the sharp dendrite, and it will cause safety problem. So I think the government and the academia, they are working on the technology issue to charge the battery faster, make the battery run safer on the faster charge, Our next question is about recycle. How do we recycle components from the discarded batteries? Is there development along the lines of reducing the quantity of lithium required to be mined? I think it's important for the recycle of the components in a battery, like lithium, cobalt. How to recycle is a bigger problem.
Yeah, definitely.
Steps, different chemicals to purify the components, to separate the components in the battery.
It was interesting.
Yeah, I think there's, with
Right.
just an interest of being sustainable, we're seeing many customers, corporations wanting to have sustainable operations, and that's in response to their consumers. This question of recycling and total life cycle of batteries is becoming more and more interesting. I think in the early stage of the industry, it was just about getting batteries deployed, having them out there, and many of them are now, a lot of projects aren't at their end of life for grid applications yet. So, but it's something that I think needs to be thought about and worked on so that we're ensuring all these terrific environmental benefits of using batteries in your electric system are then also realized at the end of life. So that's something we think about, but there's, I would say for the students and anyone else listening to the panel today, I think that's an area that, would be great to have more research and more thought put into. And I really do think you're going to see more interest from customers in really understanding how to recycle what they're using. So I think it's a great question. I think it needs some additional work, but I think it's an opportunity that can be worked on.
Thank you. Due to the limit of time, we need to go to our next question. Next question is, how can energy storage benefit organization looking for a smart, resilient, and a safe working environment, while also being cost effective. Basically balance the cost and the performance.
Yeah, I'll jump in. Oh, sorry, Brad. Yeah.
No, you go ahead, Judith. I was going to say that you made a good point on this earlier anyway. So
yeah, I was
you
going
should
to say
speak to it.
that's really at the heart of what I'm doing on a daily basis at Amoresco, because we work with customers that are looking for smart, resilient solutions. So adding storage into their energy portfolio so they can better utilize on-site renewables, have that resilience and backup capability, it is something that I think can make a lot of sense. And so any end user looking at making upgrades to their energy infrastructure should certainly consider batteries and standalone batteries and batteries paired with renewables. I'll also add, we had a really interesting case study with one of our customers. We do a lot of work with schools. This is a project that started a few years ago, but we're working with one of the Massachusetts communities to make their buildings, they're looking to have net zero schools. And so we worked with them to add solar and storage across their, basically all their schools. And one of the reasons that now is really benefiting them is they wanted to have very good ventilation in their schools. So they put health as a focus, and this was prior to COVID. And in order to, in essence, pay for that higher quality HVAC system with better ventilation, they used the savings that they got by generating solar and utilizing storage and some of the incentives that Massachusetts has. So when you look at your overall portfolio, it's interesting to see that adding solar and storage on site can actually also enable upgrades to infrastructure like air conditioning that is providing better ventilation. So it was really interesting. That started a couple of years ago, but we really are seeing the benefits for that school system now in the given environment. So I think there's some real opportunities to think about storage in a portfolio and how it can be used not only for the storage benefits, but then those savings be used for overall on-site benefits as well.
I'm sorry. So
Panelists and our moderator, this was really great discussion. We're going to start with the Q&A at this point. We have a lot of people with a lot of questions, and they're really looking to pick your brains. So the way this would go is I'll ask a question to one panelist for like a primary response, and then everyone else can just comment in whenever. So the first question: what challenges are facing customers that want to pair solar with storage?
Yeah, that's a great question. So I think cost continues to be an issue in some instances where there's good incentives. It makes sense. Massachusetts has a storage adder in its solar program. So always needing to look at the cost. So our goal is always to lower the cost of energy for our customers. But then the other is there's still some on-site permitting issues related to the safety of batteries. But that said, I think that we're just seeing a ton of interest, and if we can make the numbers work, if it works in that local area, we're seeing a lot of interest from the customer because of the benefits it can provide. And in particular, if you can add that islanding capability as well, that was brought up, so that you can have resilience. Yeah, and I'll just jump back in that's a similar model to what we do. So we're looking at whether we can make the economics work so that we can basically just have it paid for through through what they're paying for their energy.
Like a PPA, right?
Yeah, right. So that's the kind of tool that you are definitely seeing growth in, so that you can enable these technologies for